Have you ever wanted to run your very own movie theater? Well, you're going to need a couple things first. You're going to need a place of operations, a selection of movies, and most importantly, a way for your customers to buy tickets. Everything seems great until a crisis occurs. There's no way for your customers to reserve their own seats, no way for parties or a group of friends to buy the tickets online. As soon as those doors swing open, it's pure chaos and anarchy. People are finding the best seats, popcorn being thrown everywhere, and nobody's enjoying the movie. If only there was a simple solution to fix all this. Well, let me introduce to you the movie reservation program. This program will simplify the whole booking process, allowing more structure and management. The customer is able to pick a day, a time, a movie, and see all seats for that movie. Want a single seat? Done. Want to book for a group of friends? It's just that easy. Want to book an entire row for a screening? We accommodate for that too. Customers are able to save and book as many reservations as they want to their heart's desires. This will also allow customers to book their movies online, allowing more time in your theater to be allocated to other issues. Simply inform us on your theater's current selection of movies, the time they screen, and the day they screen, and it's just as easy as that. An easy program with an easy way to book, an easy way for you to get a hold of some easy profit.
We built a pretty expensive JUnit suite to make sure that every part of the system behaves the way it's supposed to, especially under weird edge cases. First, we can cover concurrency scenarios. Our reservation system reads and writes to a shared object database, so we wanted to guarantee that two users reserving seats at the same time wouldn't corrupt the file or overwrite each other's data. We wrote tests that launched multiple threads performing reservations simultaneously and then verified that the final database state was consistent and had no duplicate seat assignments that had slipped through. Next, we tested state transitions across the full reservation flow. Every major object, movies, seats, users, and reservations, was tested moving between states. For example, a seat going from available to reserved, a user gaining or losing a reservation, and a reservation transitioning from selected to purchased. These tests exposed logic issues early before we even built the full UI. We also validated successful and failed authentication. That included testing correct login, incorrect passwords, non-existent users, and deletion logic. We made sure the system responds safely with no ghost accounts, no leftover reservations, and no bypass paths that accidentally let you skip the login. Since our project relies on file-based persistence, we tested that thoroughly too. Every write to object_database.txt is verified by reading the file back in and making sure the stored objects match what we expected. We also tested append behavior, reset behavior, and whether corrupted or partial files throw predictable exceptions. Finally, although GUI components are harder to unit test directly, we still wrote tests to verify that our GUI pages work at the logic level. For example, clicking buttons triggers the correct backend calls, selected movies pass correctly into seat pages, and payment confirmation actually writes to the database. Overall, the test suite doesn't just check if the code works. It's checking how the system behaves under stress, under invalid inputs, and across the full life cycle of a reservation from login to payment.
Talk about the functionality of our code. So for phase one, we had to build the database, and we ended up having four classes in our database. A user class, which represents a user's account, username, password, and the reservations of said user. A movie class, which represents the movie showing. So a movie title, the showing date of a movie, and the showing time of a movie. The seat class, which represents a theater seat. So it would have its seat number, and the two sections in the movie theater, a regular section and a section for events, where in the regular section you could book individual seats and as many seats as you like. And for the section for events, only a row would be able to be booked. The price of tickets, which changed per section, the availability of a seat, and the buyer ID. For the reservation class, it linked all of it together. So it had a user, a seat booking, and a movie showing. For phase two, we had to build the server-client architecture. So our server created new threads for each client and handled logging, booking, and cancellation. The client was a terminal-based interaction which sends users' input to the server and displays the server responses. So we had a couple of key design details for this phase: static variables as well as synchronized file access. The synchronized file access prevents two users from booking the same seat simultaneously. We also had serialization. Serialization is important as it saves the information, so that when we rerun the program, it can still read the saved reservations. We also had to make the entire code thread safe. This is as the server runs multiple client threads and all of them access the same database file. Now, for our data storage, we ended up going with a text file. So each reservation is serialized and appended into the file. Now, to check if the seat was taken, we'd have to read all the reservations and then compare the movie and the seat. To delete, we'd again read all reservations, filter out the target, and then rewrite the entire file. For phase 3, we had to build a GUI display. So this was sort of the flowchart of how our entire website worked. A login page which creates or logs you in. A date page which selects the date, ensuring that you can only select the date 3 months in advance. A movie page which picks the movie. See page, which again which I had explained previously. A payment page which you have to enter your card as well as a CVV. We also did validation to ensure that the card had 16 digits and the CVV was 3 digits. And then a thank you page. I will now pass on the time to my teammate who will showcase how the GUI works.
Now that we've established the functionality of the code and the overall pitch, we are going to look at what a typical user would see when they access this movie reservation system. So we start with the login page GUI. I'm just going to run this. Okay, I'm going to run it. And then the login screen pops up. There's the username. So let's say my username is my name, last name, 123. Now we're gonna do our password. Do a generic one, ABCD 234. Okay, so we're gonna do login/create account. So it says this username does not exist. Create new account. So I'm gonna click yes, and then it's account created and it shows our username. So I'm gonna click OK. And the next page it's gonna bring us to is select a date. And so the functionality of this date selecting system is that you can only select 3 months in advance, which ties back into our code that we did. So I'm going to do January 5th. So as you can see, it says the date selected is January 5th, 2026. So then I'm going to click continue to movies. And so now it's going to give a list of movie options in January on the 5th, 2026. There's Star Wars, 7 p.m., Harry Potter and the Sorcerer's Stone, as you can see the time 10 a.m., Oppenheimer 1 p.m., La La Land 1 p.m., and Forrest Gump 1 p.m. So I think I want to see Oppenheimer. So I'm gonna select Oppenheimer. I'm gonna click select a movie and it says select movie Oppenheimer. So I'm gonna click OK. Now it's gonna bring me to all the seats available. So here are the rows A through J, and these are the current seats. So I'm gonna click row C, and as you can see it says C4. This is where I want to sit. Maybe I want to sit D6, like I want my friend to sit next to me. I'm gonna click done, and now it's gonna ask for the payment page to make this really realistic. So I'm gonna put in a card number, put in my CVC. Oh wait, the card number must be 16 digits. So this just adds a realistic factor because in the real world, your card number is 16 digits. So I'm gonna 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And let's say I did my CVC as 5 digits. It's gonna say CVC must be 3 digits. Click pay, payment successful. We get the thank you page. Thank you for using Movie Selector. I'm gonna click exit and the program ends. So I hope you guys enjoyed a little run through of what our movie reservation system looks like from the user end.
All right, hello. My name is Emily, and this is the frequently asked questions part of the project presentation. So, two questions that the recruiter might ask would include, let's say if this were deployed in a real theater, how could it scale, or how easily could it scale or evolve? And I would say that our system is pretty scalable since right now it only holds a few movies in our database, kind of like the Indianapolis AMC theater, and only shows a few movies every day. But if we were to scale it up, we can easily add more movies to our database and increase the number of times per showing as well. We could also add cloud deployment for our databases for uh, to store more data as well as even easier access to the database data. Okay, another question would be, how does the system handle data integrity and prevent double bookings? So our server uses synchronized access around the shared reservation data so that only one thread can modify the reservation at a time. So our reservation class also double checks this logic since the system guarantees that no two users can book the same seat at the same time, even when there are multiple users trying to do the same action. Yeah, so these two questions were part of our frequently asked questions page, and I hope it was informative. Thank you.